So this word, similar, deals with the shape or symbol, a little squiggly here. And so what does it mean to be similar? Well, to be similar, it means that two shapes have, well, basically the same shape, but they're different sizes. And so when we talk about triangles being similar, we have a few properties that we can use to prove whether or not triangles are similar to each other. And the first one is the AA, or the angle-angle similarity theorem, abbreviated AA with a symbol for similarity. And so the way it works is, let's go over to the right here to this diagram. You'll notice that angle K and angle Y are the same. And we also notice that angle J and angle X are the same. So because of that, if the third angles have to be congruent also, and I can mark those off as well. So if the third angles are congruent, that means that angle L is congruent to angle Z, so all the angles are congruent. Since all the angles in the triangle are congruent, that's enough to say that the triangles are indeed similar. Same shape, different size. Now we only need to show that two angles are congruent to two other angles congruent to another triangle, because the third angles are going to be congruent. So let's take a look at this situation next, right here. Determine whether the triangles are similar. If they are, we want to write a similarity statement and explain why. So by the angle-angle similarity theorem, if we can find two angles congruent to two angles in the two different triangles, we can say the triangles are indeed similar. Same shape, different size. So if we look at this, in triangle CDE, we notice we have a 26-degree angle and a 90-degree angle. So the missing angle right here would have to be, because triangles add up to 180, we have 90 and 26, and that is 116. And that tells us that angle E is going to be 64 degrees. Well, guess what? In the two triangles, we have two triangles that have two sets of congruent angles, 64 and a 90. The missing angle K would also be 26. So we can say the following, that triangle CDE is similar to triangle, now angle C would match up with angle K. Angle D is a right angle, it matches up with angle G. And angle E matches up with angle H. So why are the two triangles similar? Because of the AA, angle-angle similarity postulate. Let's look at one more example. Show that the two triangles are similar. ABE, that is the small triangle right there. And ACD, the big triangle. So you'll notice we have a 52-degree angle that the little triangle in blue and the big triangle both have that are congruent. Now you'll also notice in the two triangles that they both have a vertice A. They both have an angle A. And this angle A up top here is actually in both triangles. So both triangles, the small blue one and the large triangle, have two angles that are congruent in one triangle compared to the other. So this is also an example of the AA similarity postulate. Alright, let's jump down to the bottom. Show that these two triangles are similar. Kind of like a bow tie that we've done proofs with before. Triangle SVR over here on the left side. And triangle UVT over here on the right side. So, what would make them similar? Well, you'll notice that in the middle here we have vertical angles. And vertical angles are congruent. So, we have an A. Now, if we can find another A standing for angle, so we have two sets of angles that are congruent, we're good to go. Well, because SR and TU are parallel, and using this transversal right here, and we can use either transversal, we can see that angle R and angle T are indeed going to be the same. Okay, so if I mark those off, hey, we have enough. We have another angle, so the two triangles are similar by AA. Now last but not least, we have a shadow problem. And the sun casts shadows at the same angle. So imagine on this particular item we have a sun right in here, and it's casting shadow down. Top of the flagpole, top of the person right here. Kind of a little bit hard to see. And what we want to do is we want to go ahead and figure out, in this particular example here, get rid of all this stuff. A flagpole casts a shadow that is 50 feet long. Alright, so I'm going to go to the diagram here of the flagpole, and I'm going to put a 50 feet on the ground for the shadow of the flagpole. At the same time, a woman is standing nearby who is 5 feet 4 inches tall and casts a shadow that is 40 inches long. Okay, so her shadow is 40 inches. And I'm dealing with some different units here, so I've got to do a little converting. So what I want to do is I want to convert her height to inches, since the shadow is in inches. So if I think about 5 feet 4 inches, well, 5 times 12 is 60 inches, 12 inches in a foot. If we add 4 to that, we figure out that she is 64 inches tall. Now what I can do is I can actually build two similar triangles out of this situation. And they're similar because we've got right angles here on the bottom, and the angle of the sun that the shadow makes is going to be the same. Okay. So what I can do is I can set up a ratio here. So the ratio that I can use, because the triangles are similar, can be this. That the height of the person, 64 inches, makes the shadow that's 40 inches. And that's equal to, well, we have a 50-foot shadow. So the shadows are both on the bottom here. Now it doesn't matter that we're dealing with inches and feet, as long as one side is all inches and one side is all feet. So I'm going to put X feet right here. Now we're going to go and solve this proportion. So we're going to go and cross multiply. The 64 times the 50 and the 40 times the X. And 64 times 50 is going to give us 3,200. And 40 times X is 40X. So we get a value of X of 80. And we need to put proper units on that, and that would be feet, because the right side was all in feet as well. That's the AA similarity postulate to work with similar triangles. Again, triangles that are the same shape but different size. Back with more in a moment.